solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Lines of Code. This is the way the module looks, and what we have here is we have a series of different lines of code essentially. And what we're going to essentially be doing here is we're going to be taking three different variables, in this case x, y, and z, and we're going to be altering them for these first couple of lines up at the top, and then what we're going to do is we're going to try and figure out the value of n based off of this last equation down at the bottom here. So that's what we're going to be doing with this. So first things first, n is going to be essentially our submit at the top. This first little bit, int n equals 0, integer n is equal to 0. In this case, that's going to represent your submission. And as you can see, when you type letters, you can simply see that this is going to expand, essentially. And you could type in a lot of numbers here. But there is a limit to it based off of the, I believe it's based off of this down here. In this case, this 2147, whatever it is, for binary. I do believe that there is indeed a limit. I'm not sure what the limit is, but you can obviously tell that. There is the possibility of doing negative numbers, of course. So you can obviously delete these with this little back button here, and that is really all you're going to be doing with this module. So let's get right into this, and we can actually look at each of the individual codes. They have individual meanings here. Note that it doesn't necessarily need to be x, y, and z in these equations. It can actually be simply numbers in some cases, like for example, this y equals 6 plus x, right? And it doesn't necessarily have to be these variables in this exact order. Obviously, it can be switching things up, and that's going to be the way that this thing works. So, first things first, let's see what our starting variables are for x, y, and z, and that's going to be defined by these ints up at the top. In this case, we're going to start with x-ray equals 5, Yankee equals 4, and Zulu equals 2. So, this is what's going to happen here. And we're going to use the table below to determine what each line of code means. And note that when a variable gets assigned a new value, it overwrites the old value. Lines of code run from top to bottom, and so all lines above a particular line must run first, and all lines below must run after, obviously. So we're going to start with each of them in order, and remember that when we get a new value for it, and this is going to be the most important part of this module, is understanding that you are completely overwriting a new module. You're not like adding it to anything. It's just going to be replacing it. So with this first one here, we've got Yankee equals x-ray. It's a /9. And in this case, if we want to find this, we're going to take a look at this one right here. We've got our two different variables in this case that are equal to 1. And what this represents is the variable x gets assigned the value of the quotient of y and z. Specifically, y is divided by z. So in this case, what's going to happen here is if we take a look, it's going to be x-ray divided by 9 in this case, and that's what we're going to replace with Yankee. That's what Yankee is going to be replaced with. Now, one important thing with rounding, the way that this works, decimals do not matter in this case. Integers cannot have decimal points, so if a result is any decimals, you simply remove them. So if that ever happens, you will not care about decimals at all. If you happen to get a result of 0, which is indeed possible, you're going to drop everything. Drop all decimals before the actual number, and that's going to be very important to note down. So let's get back into this. So we're going to divide x-ray by 9. X-ray by 9 is going to be 5, because currently the current value of x-ray is going to be 5 divided by 9. Now note that if in further examples, if x-ray were to perhaps change or like later on, this will enter in as something else. But in this case, for right now, x-ray is equal to 5 at this position of the line of code, and we're simply going to be plugging in 5 divided by 9, which in this case gives us a decimal value. So in this case, we're going to get an actual value of 0 here. So we're going to drop decimals here, and our new value for Yankee is going to be equal to 0. We're going to overwrite the 4, and it's going to be 0 now. Next up, Yankee is going to be equal to Zulu, and it looks like a dash, 0, which in this case, a lot of these are pretty straightforward to understand, is going to be equal to minus. It's going to be Zulu minus 0. So the variable x gets assigned the value of the difference of y and z, specifically y minus z. So it's going to be Zulu, the value of Zulu, minus 0, which is nothing, is going to be assigned to Yankee. So 2 minus 0 is going to be equal to 2. 2 is going to be the new value for Yankee. Okay. Most of these are actually pretty straightforward to understand. This first little bit, I would argue, is very easy if you've seen, for example, modulo. But when we get into some of the more logic gates, it's going to be a bit interesting and it's going to be a bit weird, especially for those of you who have not actually seen how logic gates work, in this case with the lines of code. And there's going to be a couple more that I'm going to need to touch base later on, but for now, most of these are pretty straightforward of what you need to do. Our next example is going to be 6 plus x-ray. Now 6 plus x-ray is going to be exactly what you think it is. It's going to be adding. It's going to be the sum of these two. So x-ray is worth 5, and it's going to be 5 plus 6 is going to be equal to 11. 11 is going to be the new value for Yankee. Note that these do not have to be kept onto one digit in this case. That's not it. That's not how this works. You can obviously have more than one digit per number. In this case, Yankee is equal to 11. Now we're going to get into some of the more interesting commands. We've got Yankee modulo equals Yankee. In this case, this is going to be right here. It modulos the value of x by y, then assigns that value to x. And in this case, what's going to happen here is the current value of Yankee is going to be moduloed by the current value of Yankee, which is going to be 11. It's going to be 11 modulo 11, which for those of you who do not know how modulo works, it's essentially you're going to keep subtracting the specific number that you're going to be modulating by until it is less than that. And in this case, 11 mod 11 is going to be equal to 0. And the new value for Yankee is going to be equal to 0. Okay, next up, we've got x-ray equals 3 plus Yankee. 3 plus Yankee is going to be 3 plus 0. So that's just simply going to be 3 for x-ray. Okay, next up, we've got Zulu plus equals Yankee. So plus equals is going to be equal to what? It increments the value of x by y, then assigns that value to x. So in this case, we're going to be adding a specific value, in this case Yankee, to the Zulu that we currently have. However, this Zulu is currently 0, so we're adding 0 to the 2, and that's going to be it right there. Alright, x-ray equals Zulu. In this case, all that's simply doing is just replacing the value with what equals Zulu. So x-ray is going to be replaced with the value of Zulu, which in this case is 2. So x-ray will become 2. And finally, for the last one that we have here, before we get into the final command, is going to be Yankee equals x-ray ampersand, or and 1. Now, what does this mean? The value of x gets assigned the value when you use an AND gate for input y and z. So now what we need to do is, this is the bit where this is the thing where things get a little bit interesting. This is going to be where logic gates are going to come into play here. I'm going to make sure to get rid of my notification here. This is where things are going to get into play with logic gates, and here's where things get a little bit interesting. Note that all numbers used in this module are 32-bit integers. Now, this is not going to apply for every single case that we're going to have to worry about, where we're going to have to write out 32 bits of numbers here. But in some cases where it happens to be, for example, shifting left or shifting right, especially shifting left, that's the one you're going to really want to pay attention to. In this case, a lot of the times you're just going to have to simplify the binary that you get for the gates that you have to get. So in this case, we're going to be using an AND gate. An AND gate is exactly if both are true. In this case, when they're applied. And if we take a look at 1, this is where things get a little interesting. So we're going to bring this down a little bit. For those of you who do not know binary, I would advise you to know how binary works before getting into this tutorial. I should have mentioned that beforehand. But especially with binary and logic gates, this is going to be very, very important. I will include descriptions to both of these in the description, because understanding how logic and how binary works is essential to this module. It is absolutely imperative that you do know how this works. I'm going to make sure that my voice is on too. Good, it is. So let's take a look and let's see what we need to do. I'm going to explain this as if you know what AND is, but I will explain what the gate actually is. AND is simply when both values are equal to 1 in a specific position. Now, if we take a look here, we're going to break these up in binary. X-ray in binary is equal to 2, so it's going to be A 0, 1, 0. And for 1 in binary is going to be equal to 0, 0, 1. Note that in none of these positions, both numbers happen to have 1 in the exact same position. Therefore, what's going to return as a result is going to be 0, 0, and 0, which in this case is, as you guessed, a binary total of 0. And this is going to be assigned to Yankee, which happens to already be 0 already. So that doesn't do anything for us. Now, we've reached the end of our equations here. We've reached the end of these, I think it's always 8 equations. And now what we need to do is we now need to get the value of n in our submission. And there's going to be 3 more things that we have to go through here, or 2 more if you think about it like that. And essentially what's going to be happening here is all 3 variables are going to be used in some way, shape, or form. In this case, X-ray is going to be asterisk Zulu. And then what we have here is Yankee minus whatever the result of this parentheses is. So we're going to do X-ray minus Zulu. And we can already set up the Yankee, in this case, 0 minus and X-ray asterisk is going to be the product of the Yankee and Zulu, so it's going to be X-ray and Zulu, so it's going to be 2 times 2, in this case, is going to result in a 4. And then now what we're going to do is we're now going to do 0 minus 4 is equal to negative 4, and now November is equal to this value. In this case, negative 4 will be our answer. 4 and then negative, make sure you type in 4 and then make sure it actually goes into negative. You obviously cannot have a negative 0. In this case, as you can see, negative doesn't work. Let's type in 4, let's hit the negative, and just like that is a solved module. Now let's go over one more example. I want to make sure I get some of the trickier ones in here. We did get some logic gates, but I do want to get some, how do I describe it, a bit more chaotic examples. Or rather just one more example, that would be nice. So let's see what we can do here. And we can be done with this tutorial. Overall, not that hard of a module to understand. Just be careful of the fact that this is, it's especially important to understand that 32 bits does not mean up to 32 in decimal. It means exactly what you think it is. It is exactly 32 bits long. It is quite a lengthy string here. And especially with cases like shifting left and right, for example. So say if you were to have, for example, that would be 16 and 8. For example, 24 in decimal. 24 in decimal would be this in binary. And if we were to essentially shift left by, like say, for example, 5, what would happen here is that these values are going to be getting, when left shifting, any newly created bits will be 0, and when right shifting, any newly created bits will have the same value as the original most significant bit. So in this case, if we're going to be shifting to the left, these zeros are going to go, and now what we're going to do is we're going to add zeros to the end. It's 1, 2, 3, 4, 5. And now, as you can see, if you already get a pretty good idea, this number has increased significantly based off of this position here. So when it went from 24, and if we were to copy this into a base converter, which I'm going to use right now, if we were to copy this sucker into a base converter, it goes to 768. That is how drastic this module can be, and it's very important that you make sure that you understand how how to actually do like the 32 bits here, and it's very important that you have that in the back of mind. In cases of logic gates, you don't really have to use that much of the 32 bits because of the fact that the numbers are small enough, or they share enough. They only share like a maximum amount of digits, whereas it would only have to have, like, for example, 5 digits present. So we have to have like a 11001 or a 01110, for example. And if you were to OR these, this would be quite simple to do. This would be 11111, for example. So that's kind of what the deal with it is. You don't need all 32 bits for most logic gates, but in some cases you might. So just bear that in mind. And let's get one more example going, and let's see what we get. Hopefully we get some nice examples. The nicer it is, the better. But just bear this in mind that this is likely to happen. These examples are a bit weird. And let's get this thing going. Okay, this is going to be a bit interesting. And we get XOR gates, that's good. We get a modulo, good. We actually do get some shifting to the left. That's going to be, guys, that's going to be good for us. And we get some shifting to the right. Okay, interesting. So we get X-ray equals 4 to start us off. We get Yankee equals 6. And we get Zulu equals 0. So our first one is going to be 1, and it's going to be 2 carets. It's going to be greater than symbols in this case, for those of you who are familiar with that. And it's going to be Zulu. The variable x gets assigned the value when you bit shift the value of y to the right a Zulu number of times, which in this case is going to be quite easy to do. So the value of 1 in binary is going to be just 0001, whatever you want to call it, where 1 is the last digit present. But in this case, we know for a fact that Zulu is actually going to be is assigned as 0. We're not going to be shifting anything at all. So we already know that we can assign Yankee a value of 1 from this. Very simple way to actually look at that. And now, one of the things that we're going to do here is we're going to do Zulu, and it's going to be shifting to the left by a value in this case. But another thing that we can automatically realize here is that if we shift to the left at all for Zulu, shifting to the left for 0 is going to be equal to 0. Every single bit in the 32-bit for shifting to the left is going to be equal to 0. So that's going to be quite a nice case to look at here. Because in this case, this one bit shifts the value of x to the left by a y number of times. So in this case, it would be shifting to the left by x amount of times, which in this case would be 4. However, as we just mentioned, Zulu is equal to 0. So in this case, Zulu is going to be staying as 0 for that example. Next up, we've got asterisk equals. Asterisk equals is going to be multiplies the value of x by y, then assigns that value to x. Fairly simple. So we're going to multiply x-ray, and we're going to multiply you by 2. So it's going to be 4 times 2, which is going to be a total of 8. That is going to be the new value for x-ray. Next up, we have Yankee equals x-ray divided by 4. So Yankee is going to be assigned something and x-ray equals 4. So x-ray is going to be a slash. X-ray is going to be divided by 4 in this case because it's the quotient, y divided by z. So x-ray is going to be an 8 divided by 4. And in this case, we actually get a perfect value from this. That is going to be Yankee equal to 2. New value. Next up, Yankee is equal to 3 percentage sign Yankee, which in this case represents modulo. 3 modulo 2 is going to be a total of is going to be 3 minus 2, which is going to be 1, and 1 cannot go below anymore, so that is going to be a value of 1 in that case. Yankee is going to be now equal to 1. Next up, we've got x-ray modulo equals x-ray. We've had this one before. Modulo is the value of x by y, or in this case, x-ray is simply moduloing itself, which is going to be equal to 0. Because 8 mod 8 is 0. Zulu is going to be equal to 4 vertical bar Zulu. 4 vertical bar Zulu is going to be up here. The variable x gets assigned a value when you use an OR gate for inputs y and z. So in this case, we're going to convert 4 into binary, which is going to be a 0, 1, 0. And we're going to convert Zulu into binary. In this case, that's going to be 0, 0, 0. It's still 0. And now what we're going to do, or excuse me, 0, 1, 1, 0, rather, for 4. And we're going to use the OR gate. In this case, the OR gate has to have at least 1 present in the inputs here. So that's going to be a 1, 0, 0. And that's going to be giving us a total of 4. Now 4 is going to be plugged into Zulu here because Zulu is equal to 4 OR Zulu. And finally, for our last one that we have here is going to be Yankee. I believe that's a caret. Anyways, it's an upside down V equals X-ray. So this is going to be an XOR gate between X and Y. So X is going to be equal to 0, 0, 0, or just 0 in this case, and Y is going to be equal to 1. And in this case, Yankee is equal to 1, X-ray is equal to 0. These are both XOR specifically refers to having exactly 1 in the solution, and in this case, this returns true. So in this case, this is going to total out to 1, and 1 is going to be our final answer for Yankee. And now we've determined everything that we needed to do here. And now we've determined all of our formulas here. And November now is going to be equal to the total amount of Zulu plus X-ray in the first parentheses here, plus Yankee. So it's simply adding everything together. This is another easy example that we got here. We're going to be able to input 5 into November, and just like that is a solved modulo. I keep saying modulo for some reason. I don't know why. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.